Bismillahirrahmanirrahim. Today we are going to discuss exercise 1.4. Exercise 1.3 is based on graphs. We will discuss it later. So, question number 1, part A, limit x tends to minus 2 x square plus 3x minus 7. We will apply the limit on each term and then we will put its value. So we can write it as limit x tends to minus 2 of x square plus 3 limit x tends to minus 2 of x minus limit x tends to minus 2 of 7. Now put the x value here, minus 2. Minus 2 square plus 3, the x value minus 2. And note that the limit of a constant is that constant number. So we can write it here, minus 7. Now minus 2 square we get 4. 3 2s are minus 6 and minus 7. Minus 4 minus 6 we get minus 2 minus 7, which equals 2 minus 9 is the limit of this question. This is the answer. Similarly, part B, limit x tends to 3 x plus 5 into 2x minus 7. So solution, we can write it as limit x tends to 3 of x plus 5 into limit x tends to 3 of 2x minus 7. Now put the limit value, x value 3 plus 5 into 2 into 3 minus 7. 3 plus 5, 8, and here 6 minus 7. 8 into minus 1, which is equal to minus 8, is the answer. Part C, limit z tends to 1 z square plus z minus 3 divided by z plus 1. Solution, apply limit on numerator and denominator separately. So limit z tends to 1 of z square plus z minus 3 divided by limit z tends to 1 of z plus 1. So here 1 square plus 1 minus 3 divided by 1 plus 1. 1 plus 1 minus 3 divided by 2. So 2 minus 3 divided by 2 minus 1 divided by 2 is the answer. Similarly, part 4, is limit x tends to 4 of 1 over x plus 3 over x minus 5. Solution, take limit on each term. Limit x tends to 4 of 1 over x plus limit x tends to 4 of 1 over x minus 5. Now put the limit value 1 over 4 plus 3 4 minus 5. 1 over 4 plus 3 divided by minus 1. So 1 over 4 minus 3, minus into plus minus. Now take the LCM. 4 is the LCM. 1 minus 12 minus 11 by 4 is the answer. Now try part E by yourself. Look at part F. Part F1 is limit x tends to 1 under root x minus 1 divided by x minus 1. When we put the value 1 here, so 1 under root equals to 1, 1 minus 1 0, and here 1 minus 1 0. So it is of 0 by 0 form. Now we will rationalize the numerator. How? Divide and multiply by the conjugate of numerator. So solution, rationalize the d by rationalizing the numerator. Limit x tends to 1 x minus 1 divided by x minus 1 into under the root x plus 1 divided by under the root x plus 1. Limit x tends to 1, a plus b, a minus b form it is. So we can write it as under root x square minus 1 square divided by x minus 1 into under the root x plus 1. Now limit x tends to 1. Here we get x minus 1 and x minus 1 under the root x plus 1. This x minus 1 cancel with this. So we can write it as limit x tends to 1, 1 over under the root x plus 1. Now put the value of the limit. So 1 under root 1 plus 1, we get 1 plus 1, 1 by 2 is the answer. Part G, solution. Limit x tends to 0, 1 over x plus 3 minus 1 over 3 whole divided by x. We can write it as limit x tends to 0, 1 over x and 1 over x plus 3 minus 1 over 3. This is in the denominator, so we can write it separately as and this. Now take the LCM here. Limit x tends to 0. Here the LCM is 3 into x plus 3. So 3 times 1 is 3 and minus x plus 3 is multiplied by 1. So we get this. Limit x tends to 0, 1 by x. Here 3 minus x minus 3 divided by 3 into x plus 3. Now this 3 cancel with this 3. We get limit x tends to 0, 1 by x. Here minus x, 3 into x plus 3. This minus this x cancel with this. So we get limit x tends to 0, minus 1 over 3 into x plus 3. Now put the limit value. Minus 1, 3 into 0 plus 3. 3 into 3 minus 1 over 9 is the answer. Part H, solution. limit x tends to 1, 1 by x minus 1 divided by x minus 1. We can write it as limit x tends to 1, 1 by x minus 1 into 1 by x minus 1. Separate these two. Now take the LCM here. Limit x tends to 1. X is the LCM, so we get 1 minus x into, look, x into 1 we get minus 1 minus x, like this. Now take minus 1 common from the numerator. Limit x tends to 1, minus 1 common, so we can write it as x minus 1 divided by x into 1 over x minus 1. This x minus 1 cancel with this. We get limit x tends to 1, minus 1 over x. Now put the limit value here. So minus 1 divided by 1, which is equal to minus 1, is the answer. Part I. Limit x tends to 0, 1 minus sin x divided by cos square x. So we can write it as limit x tends to 0, 1 minus sin x, and cos square x we can write it as 1 minus sin square x. Further we can write it as limit x tends to 0, 1 minus sin x, and this 1 square minus sin x square. Further we can write it as limit x tends to 0, 1 minus sin x divided by 1, a square minus b square form is this, so we can write it as 1 minus sin x into 1 plus sin x. 1 minus sin cancel with this 1 minus sin, so we get limit x tends to 0, 1 over 1 plus sin x. Now put the limit value 1 over 1 plus sin 0. Using calculator we will find that the sin 0 value is 0, so 1 over 1, which is 1 is the answer. Part J. Limit x tends to 0, tangent x by x. It is 0 by 0 form. How? Tangent 0 value is 0 and x value when we put 0 here, so 0 by 0 form. So we will solve it like this. We can write it as limit x tends to 0, 1 by x tangent x. Further we can write it as limit x tends to 0, 1 by x tangent x is equal to sin x divided by cos x. Further we can write it as limit x tends to 0, sin x divided by this x into 1 by cos x. Now apply limit on both these, so we can write it as limit x tends to 0, sin x divided by x, limit x tends to 0, 1 by cos x. Keep this in mind that limit x tends to 0, sin x by x, this is equals to 1 by definition, and put the value here, so we get cos 0. By using calculator we will find that cos 0 value is 1, so 1 into 1 over 1, 1 ones are 1 divided by 1, 1 is the answer. Part K. Limit x tends to 0, secant x minus 1 divided by x into secant x. If we put the value 0 here and here and here, so we will get 0 by 0 form, and 0 by 0 form is indeterminate form. It it is undefined. We know that something divided by 0 equals to infinity. So we will try to solve this solution. Limit x tends to 0. Secant x can be written as 1 over cos x minus 1 divided by x and 1 over cos x. Limit x tends to 0. Take the LCM cos x. So 1 minus cos x we get, and here we get x into 1 over cos x. Now look, this cos x cancel with this cos x, so we get limit x tends to 0, 1 minus cos x divided by x, which is also 0 by 0 form. Put here 0, cos 0 value is 1, 1 minus 1, 0, and 0 by 0. So we will rationalize the numerator. Rationalize the how? Limit tends to 0, 1 minus cos x divided by x. Multiply it by 1 plus cos x divided by 1 plus cos x. So we get limit x tends to 0, a minus b and a plus b form, so we can write it as 1 square minus cos x whole square divided by x into 1 plus cos x. We get limit x tends to 0, 1 minus cos square x divided by x into 1 plus cos x. Further we can write it as limit x tends to 0, 1 minus cos square x value is sin square x divided by x into 1 plus cos x. Further we can write it as limit x tends to 0, sin x divided by x and sin x divided by 1 plus cos x. This is sin square x, so we can write it as 2 times sin x. Now multiply the limit on both. We know that limit x tends to 0, sin x by x value is 1, and so take limit x tends to 0, sin x by x into limit x tends to 0, sin x by 1 plus cos x. Now limit x tends to 0, sin x by x value is 1, and here put 0, sin 0 by 1 plus cos 0, so 1 into sin 0, 1 into sin 0 value is 0 divided by here sin 0, 1 into sin 0 value is 0 divided by 1 plus cos 0 value is 1. So here we get 0 divided 0 into 1 0 and 1 plus 1 2, 0 divided by 2 we get 0, the answer. Try part L by yourself. Question number 2, part A. Limit x tends to 4 minus 6 divided by x minus 4 whole square. So direct put here the limit 4 minus 4 whole square, so minus 6 by 0 square minus 6 by 0, which equals to minus infinity, or we can write undefined. Part B, limit x tends to 0, 1 over x plus 3 minus 1 over 3 whole divided by x. So solution, we can write it as limit x tends to 0, 1 over x plus 3 minus 1 over 3. Further, we can write it as limit x tends to 0, 1 over x, take the LCM, 3 into x plus 3. So here 3 ones are 3 and here x plus 3. Now limit x tends to 0, 1 by x, here minus 3 minus x minus 3 divided by 3 into x plus 3. This 3 cancel with this. Limit x tends to 0, 1 by x minus x, 3 into x plus 3. This x cancel with this. So we get limit x tends to 0, minus 1 over 3x plus 3. Now put the limit value here. We get 3 into 0 plus 3 minus 1 over 3 into 3 minus 1 over 9 is the answer. Part C. This is also 0 by 0 form. So rationalize the numerator. Which is equal to limit x tends to 5 under the root x minus under root 5 x minus 5 into under root x plus under root 5 divided by under root x plus under root 5. We can write it as limit x tends to 5, a minus b, a plus b form. So under root x square minus under root 5 square divided by x minus 5 into under root x plus under root 5. We get limit x tends to 5, x minus 5 divided by x minus 5 into under root x plus under root 5. This x minus 5 cancel with this. We get limit x tends to 5, 1 over under root x plus under root 5. Now put the limit value here, under root 5 plus under root 5. We get 1 over 2 under the root 5. This is the answer. Part D, try by yourself. This is also 0 by 0 form, and you will rationalize the numerator. By the same manner you will get the answer 1 by 10.